Okay, good morning. This is Leroy Wong with the BHS Help Desk. So this is our first day of Computer Science Education Week, or Hour of Code. I'm happy to have Ms. Yanti Arifin here. So she is the mother of one of my students, Will. And so I'm happy to have her today, and she's going to talk about what she does with user interface design as a developer with Desktop Metal, which is a company that does 3D printing but with metal. So thanks so much for joining us, and I guess I'll just go ahead and throw it to you and let you start, okay?
Okay, sure. So, hello everybody. My name is Yanti Arifin. I am the UX design lead on the software team at Desktop Metal. I don't know if many of you have heard of Desktop Metal, but we're a company right here in Burlington, and we make metal 3D printers. I imagine that many of you have had experience using 3D printers. Um, our 3D printer, we have different systems. We have some that are, so metal 3D printers are different than plastic ones in that they're big. And metal 3D printers also require sintering. But before I get into Desktop Metal, and I'm just going to talk, but if anybody has any questions, this is going to be interesting to do this virtually, but I guess you could stop me and ask me. If you have any questions, I guess you can. You have a way to raise your hand, I guess. I've never used
Right.
that
And
before.
also, Ms. Arifin, there is a chat, so people that are on can also use the chat too.
Great, great. Okay, so just to start with how I got to where I am today, as far as my work experience goes, I didn't actually go to a technical school, or I don't have a degree in computer science, and I don't, I didn't. All my coding skills I learned kind of on my own. My background is in design. So I actually went to art school. I have a degree in graphic design. And when I started working, there was no internet, so there was no computer science, or especially for designers. But as I started to grow in the field of graphic design and visual design, I kind of you know journeyed into the world of web design, which was new at the time, and then that then got me into, just through the course of my career, I became more interested in the user experience aspect of that. And so that's how I ended up in the user experience. And when you're in user experience, you actually work very closely with software engineers, because you have to try to kind of make sure that whatever it is they're building and how something functions doesn't just function. Because when something functions, it doesn't really mean anything if nobody can figure out how to use it. So my job is really to work with these software engineers to make sure that we take whatever functionality we're building and making sure that it makes sense from a human perspective, so that people can use whatever it is that we're building, whether it's software. In my job, I do both pure software, which is like cloud-based software, um, just like can't think of one right now, but any kind of software that you go online to use, like Google Sheets or Google Docs. But I also do the UX design for the machines. So on our machines, let me just, as I'm talking, I guess I could start showing you stuff. So I am going to share my screen. Mr. Wong, is that something that the students have an awareness of, like data models and APIs? An
I
API is basically like
I would say maybe some of them do. I think most of us don't. I mean, as far as like our knowledge so far of any sort of 3D printing,
yep.
it's mainly just using like certain like basic CAD programs like Tinkercad, and then we
Okay.
also have like a more like a obviously a non-metal 3D printer here. So I'd say
Yep.
that's probably the extent of it. I know
Okay.
I do have some other folks listening in from another class, so I don't know if those students may possibly have some experience with that. And I'm sorry,
Okay.
I had suddenly gotten disconnected, so I had to reconnect, so I may have missed a little bit of what you had been saying. So
Oh, that's okay. I was just talking about my path, how I came from actually an art background as opposed to like a computer science background. And I also kind of dug into a little bit about, what I do at Desktop Metal. Um, and I was also, so it's hard to explain, but there's a lot of levels to building software. There is what we call the front end, which is kind of the UI, which is the part of software that, for example, if I was designing the software, okay, so really quickly before you guys start wondering why I'm showing the UI for a furnace, metal printing, because metal is so I go into kind of how metal printing works, I'm just going to say that when you print metal parts, when you're done printing, it's not done. You have to sinter it. You have to put it into a furnace and bake it at a really, really high temperature so that you get rid of all um, the holes inside, and it densifies and becomes like a true metal part. When after sintering, metal part then becomes, 99.9% pure metal. So I hope that makes sense. Really quickly, I'm gonna stop sharing for a second just so that I can actually show you guys, because I have in front of me, and wow, it's really bright in my room. I don't know why that is. Okay, there you go. It's because of my window. Sorry about that. So this is like a metal part. Um, and this is like another metal part. This is like a keychain. So these are all 3D printed, but they're metal. See, but in order to get it to be this hard and to this point, it actually you have to bake the print, because when you print it in our studio printer, the filament that you use are actually rods, and it's about 70% metal and 30% binder material. And the reason why that binder material is important is because it needs to the metal compound has to squeeze through a filament and be soft enough for you to form your piece. But in order to do that, there's like a bunch of binder in it. So that's why it has to get sintered. And went through the sintering process, there is what's called thermal debinding. There's a thermal debinding process where it literally dries out all that binder material and shrinks your piece. And so in the software, for example, when people in the software that people use to prepare their parts for printing, we have to add that the math so that when the part is finished, not finished printing, but finished at the end of the process, it is to the size that the user has kind of specified. And so I'll just show you the slicer. So in 3D printing, before you print, you need to what we call slice the part, which is take a model of a part and break it into layers. And I'll show you kind of the slicer that the cloud we have a couple of different slicers, but we have a cloud-based one which I will show. So I'm going to go ahead and present again. I'm assuming that people can see my screen. Let me know if you can't. Okay, so let me just log into. So this is our cloud-based slicer. This is what you have to do before you print. So maybe this will make more sense as I go through this process. But okay, so let me see. Give me 1 second. Okay, So we'll take this piece right here. So what I'm doing right now is I took an STL file, and an STL file is basically okay. So the process of what designers and engineers do is they will design a part or they will design an object in like a CAD software. That is something we don't do. So that's typically people use like SolidWorks or Fusion 360. In the case of I actually use Tinkercad because it's easier. CADing is not one of my strengths, but I do like to make parts once in a while. But I think a lot of you guys use SketchUp too. So once you're done with designing your part, whatever it is, you then export it into an STL file. This is where this software picks up. You then import that STL file to prepare it for printing. And so, for example, here's my part. It's giving me a quick preview. I will go ahead and save and continue. And then now I've got this part ready to slice. And so the way, what you now do in the slicer is you're no longer designing the part. You are now going to prepare this part for printing. And so you may want to change the orientation. And if you know about filament, using filament or 3D printing with plastic printers, you'll know that the best thing to do is to not, if you have anything at an angle, you might get a stepped pattern. So if you want things to be smooth, you probably want to find the best orientation for it. For example, if you can't, this would be a terrible orientation to print because you'd have to have all this support material because as the filament comes down, it can't rest on thin air. So it's got to create supports. So this is probably the best orientation. So, you can set it up however you want. You can even change the settings. For example, the higher the layer height, the less the resolution. So this is, and then when you're ready to see how it'll print, you slice it. And what slicing does is it'll take this model and it will then cut it up into many, many different layers. And I'll show you what that means in a second when this is done. Okay, so let me I'm going to unclick the unprinted so you can see. So you'll see that, so this now then shows you how it's going to print. And you'll see that so this purple part, that's where the supports are. If I go back and say for example, I change the orientation and then I slice it again. Okay, it's slicing. You'll see all this purple, that is supports, which you will have to remove. And we try to make it easy, but really it is a pain to remove, and you don't want to have to remove supports on faces that are important for it to be smooth. So for example, when you do print it out this way, you would have to actually break off this purple part. One of the things that when you do metal printing, it's important that the support material and the part material is the same density, the same material. The reason is if it's not the same, if for example, the support material has a different rate of sintering than the part material, you'll start to get warping. And so it has to be exactly the same. So the problem with that is, how do you break off a metal piece from a metal piece? So we have, and this is proprietary to Desktop Metal, we have this layer called the interface layer. And let me just show it to you. Between the pink and the part and the gray part, which is the actual part, is this purple part. And this purple section is a layer of ceramic that we put in between the support and the part, so that when it's in the oven and it's sintering, because ceramic has a much higher sintering temperature, what happens when the part is done is while the metal part, the metal support and the metal part is completely sintered, so it's like really hard and really um, pure metal. The purple part that separates the supports from the actual part is still crumbly, and so you can literally break that support off by hand. Um, so I hope that made sense. Again, if anybody has any questions, just let me know. Okay, so once you're happy with, we'll just put this back to, oh, and we also put in an auto orient. So what auto orient does is the software will actually look and try to figure out what is the best orientation for your part. And these are all done in the back end by, you know, algorithms and things that the software engineers do. That's the part of software development that I do not do. The part that I do is the part that you can see and you can touch and you can interact with. Okay, so once we're done slicing and previewing, oops, I probably shouldn't have done that because now I have to reslice it. In the case of, because we want to give people a chance to focus on the part first before creating a job with multiple parts, we focus on the individual part, and when that is done, we then allow we then put it on the virtual print bed. And so this is where you can, if you want to print 2 of the parts that you just customized, you can go ahead and print 2 or 3. You might be wondering why. Okay, so the other thing is what the software does is it will auto nest. So if you add more parts to it, it's going to kind of put it in the position on the print bed where it thinks it's the best place to be. You may be wondering why it's not in the center. The reason why it's not in the center is at one point our printer was cantilevered, and so this was like a bed that there was a support in the back of the print bed, and so this was actually if you have a heavy part, that would actually be the best place to put it because that's where the support is. So once you have your print bed set up, you then go ahead and you send it to the printer. When you hit send to printer, it's going to again generate the G code. Okay, so G code is I can explain to you what G code is. It's essentially okay, so it's sent to a printer, so it must have known. So if I go to my devices, okay, so this is a test. I'm in a test version, so there's many devices, but like usually people will have their one printer. They can then go to their printer and they can see that they can go to the queue of that printer and they can see their job in that printer. Now, the user flow normally would be after you send it to the printer, you would walk over to the printer and then you would go to the queue in the printer, open up that queue, find your job, select it, and then print it. We don't actually let people start a print remotely because there's just too many things that could go wrong in that case. Does anybody have any questions so far?
So, Ms. Arifin, it looked like there were a few questions from Ms. Belcher, and sorry, since I've been multitasking, I don't know if you had answered the first one, but one of them.
I'm sorry. Yep, I see them. I see
them. Oh, you see them. Okay, all right.
Yep. So, so the first question is the first question would be, what is the benefit of printing an object in metal instead of making the object the old-fashioned way? Oh, that's a very good question. So in metal fabrication, there is what's called subtractive. There's a subtractive method. There is an additive method, and there is what's called it slips my mind now. But let me show you a diagram that will explain. I'll go ahead and go back to presenting. Okay, so, oh, I'm sorry. I guess I'm still in presenting mode. Can you guys see this diagram right here? The formative, subtractive. Okay. So, so what 3D printing is additive. So with additive, it's literally, it starts with nothing and it forms your part as the process moves forward. With subtractive, this is kind of the traditional way. You basically have a hunk of metal, and then to make the piece that you want, you literally chip away until it's kind of like sculpting with stone. You chip away until you have the piece that you. Traditional subtractive way of forming a metal part. The other way is formative, which is using molds. And so, for example, you might have like, molds made of plastic, and then you literally pour the liquid metal in, and then once it cures and bakes, you then break away the molds. And so that's the other way. So these are pretty much, so the formative and the subtractive way are kind of the ways we've been working with metal forever. And the additive way is the new way that 3D printing kind of has brought about. And so I will say that not everything should be 3D printed. For example, if you're just making something very simple with like a divot down the middle, for example, like a beam, it would make absolutely no sense for you to 3D print that, because it would just be a lot easier to take a hunk of metal and then just route a straight divot through the metal. There's absolutely no reason why you would want to print that. That you would just use your CNC router or a laser cutter to do. Let me show you examples of parts where it does make sense to have use the additive way. So, for example, here's a part. Imagine if you had to. Let me just open up a few more. So here's some metal parts. The second one is actually from one of our clients. Imagine if you had to actually cut these parts from a hunk of metal. It would be really difficult, and in some cases impossible. Like, for example, there might be trapped spaces inside that is hard to cut because, for example, if you had to cut like this kind of curve and you had some fine detail that you had to do in here, that'd be pretty hard to do if you had to cut it. Here's another example. This would be, it would be pretty difficult to be precise, kind of doing something like this. So these are the kind of examples that you would use, probably if you had the option to, you would use 3D printing to do, just because they're, some of these shapes are kind of almost organic like, and it really hard to cut things the way, to make it exactly the right curves, the right angles. Now there's also software that uses what's called biomimicry. For example, Desktop Metal has a software called Live Parts, which actually is a way to design a part not by actually drawing it, but by telling the software what the keep out parts are, how much weight it has to carry, how much pressure it has to bear, and then the software will then form the part for you. And often what the software does is, I'll show you, let me see if I can find some live parts examples. Okay, so for example, software uses kind of the same algorithm that, the engineers have learned how bone mass grows. And so the parts that you make from using this kind of software often ends up looking very organic like this. And so imagine if you had a STL file of this. See, this is how it kind of creates your part based on the inputs that you give it. If you think about, if you end up with an STL file that looks like this, it would be really hard to cut that out. So I hope that answers the question of why you would use 3D printing as opposed to kind of the traditional way. Let me see, what other questions? How quickly can a printer turn out objects? So, okay. So how big can an object can these machines print? Okay, so the I wish I should know this, but I don't. So the build volume is it's bigger than a 3D printer, but it's not big enough to say, for example, print like you know a piece that you'll see like inside an aircraft. Well, I mean, there's a lot of little pieces inside aircraft carriers, but like it's big enough so that you can print like I'm trying to think of an example. So you could print like a little um, air purifier, for example. But it's not big enough to print like a giant, like a piston for a machine. So right now, the things that our machines are trying to accommodate is, for example, if you look at our products, the studio and the fiber system, and to a certain degree, the shop system is for like labs, prototyping. The production system is for factories, and so the goal of the production system is to print a lot of parts in one go. And so it's not really, the goal hasn't really been to print big parts, but it's been to print large volumes at the same time. I hope that makes sense. So the production line actually does have a really huge bed. It's the size of like a desk. But that said, the production system is like a $1.5 million system, as opposed to the studio system, which is like 100,000. And so the price points are kind of kept in mind of the kind of people who would be using these systems. I hope that answered the question. How quickly can a printer turn out objects? Okay, so in the world of 3D printing, this is the bane of our existence. 3D printing is really slow. So, for example, especially in metal, because the printing part of metal is pretty fast because our machines are pretty big and they're pretty powerful. But what takes a long time is the process. So, for the studio system, you make a print. And that could take, like, depending on how many parts you have on the bed, that could take like a couple hours, 3-4 hours. And then right now you still have to debind it, which is you put it into this washer, and you and it washes away the majority of that binder material that was necessary to put in the filament. And then that takes maybe like an hour or two. Then you have to sinter it. That can take up to 8 hours. So it still takes like, to make a complete metal part with the studio system, it still takes like, could take a couple days. So, but it's still faster than if you were to send out to have something, kind of cut out the traditional way, which could take 1 to 2 weeks. So it's still not ideal, but it is better than the option that we have before we had this option. Did that answer? Okay, good. So, okay, so let me just kind of quickly show you kind of the work that I do. So let me see. Okay, so let me just show you the furnace UI. So this I kind of chose this to show because it gives you an idea of kind of the breadth of stuff that I do as a UX designer. Of course, I do the visual design, and I create these documents to help everybody kind of see what every state needs to look like. Like, for example, this is what it looks like when the chamber is unlocked and it's ready. This is what it looks like when the user selects a job, when they choose a part, and then when they're starting up a job, when they're centering the job. So, I've got to, as a UX designer, I have to think of all the different scenarios that a machine goes through, and then determine how that will look. And also, there are things that the software has to ask the user to do. For example, when the furnace chamber is open after a job, they need to clear the binder trap, and then they have to remove any material. And so it's kind of a partnership effort with the user. And so, how the software communicates to the user is of utmost importance. And when engineers are kind of knee deep in trying to solve a very complex algorithm and functionality of how something works, it's difficult for them to kind of keep the user in mind because they're trying to make something very difficult actually be possible. And so my job is to keep what the outcome of what they build in check, and make sure that it makes sense to the user. And it really helps for me to kind of show them kind of the steps of what the user goes through. So I also create these little prototypes so that people can kind of get a feel of how what happens when you're going through as a user. I have to create these assets as well. So this is a visual design part. I kind of have to break things into different components and make sure that the components are reusable. So in the world of software development, you're going to hear a lot about components because components are a very important part of software development. It allows for efficiencies. So when you build a piece of software using reusable components, no matter how the software changes or no matter how many iterations or no matter how many new software comes from the software, you should ultimately have a bunch of modules that you can reuse again and again and again. So for example, there's a hero window in every single console that we design. Why would we do a new hero window for everyone? So we create a component out of that so we can reuse it. I also do the flow. So in this case, this is the way a user would journey through the process. So they would, and I literally diagram this out because you'd be amazed at how people forget how a user uses things. So the user would select a job, position the parts on the tray. They would then normalize the pressure because the pressure needs to be normalized before they can open the chamber. And so, this is the UX part of the work that I do. So I kind of chose this to kind of give you a kind of look into the documentation and the user the user first kind of thinking that I bring to the software project. One of the things that I unfortunately don't do enough of right now is user research. And that's because we are a company that's in the early stages. So we don't really, our users are pretty new. But eventually, as we build out our user research capabilities, we will be going out and talking to users, observing them and bringing feedback, kind of watching for patterns of frustration using the software, and then bringing that back to the company so that as we iterate, because with software, you always iterate towards greatness. It's never great at the beginning. As we bring that information back to, as we iterate, we can ensure that the decisions that we're making are based on data and not based on opinions. I can tell you without a doubt that the biggest end to good software is opinions, because when things are based on opinions, you have to accommodate a lot of different people's opinions and you end up having a really messy experience. And so the more data and the more user feedback and the more user research you do, the more the opinions go away and the more you can be true to how to improve software. Okay, so let me, at this point, I think I should have given you guys kind of a good idea of what I do and the breadth of the work that I do. Do you guys have any other questions right now? And Mr. Wong, how much time do we have here? Okay. Oh, that's okay. Yep. Sure. Yep. I kind of touched on it briefly, but I'll kind of explain my journey to this point. So I actually went to art school. I went to Academy of Art in San Francisco, and I got a degree in graphic design. And I actually started as an art director working at an ad agency. I worked at a really big agency, doing commercial work for like Coors beer and Gatorade and Kraft mac and cheese. And I didn't really like it because it was a lot of talking. It was a lot of, you know, coordinating and, and a lot of traveling, which at first I love, but and traveling to, TV commercial shoots are really fun, but it gets old after a while if you're more of like an introvert. Um, but then at the time, there was this new thing called the internet. And so I got really interested in that, and I wanted to learn how to build websites because I just kind of felt like, when I started looking at websites, there was a lot of scrolling text and flashing GIFs, and these were before memes, so these GIFs were like really, really lame. But I knew that this was just the beginning, and that as the web matures, it will have a need for design thinking people and people with design skills. And so I kind of saw an opportunity there, and kind of learned HTML and CSS, and learned how to code and how to build websites. And that's how I moved from offline to online. And as I started working in when I started working in web design, the jobs that I got were mostly like for promotions. So like doing, at the time, they were banner advertising and pop-up ads and stuff. And I really hated it. So but I worked at an ad agency, and those are ads, and so that's what I did. So the first chance that I got to jump over to the client side, I did, and that's when I started working on actual e-commerce sites, and looking at trying to uh, create better experiences for the users, improving the experience for the user. And that's really when I started getting into UX design. I actually went from doing, ads for Home Depot, Gatorade, Coors, to then working on Sears.com, as well as Kenmore.com, as well as .com. And also while I was at Sears, because Sears owns Kenmore, I got into doing IoT design. And IoT is Internet of Things, if you guys haven't heard of that term, but it is basically the software that you interact with on machines that are connected to the cloud. And I cut my teeth on that with Kenmore products, with like connected appliances, like refrigerators and washing machines and thermostats and things like that. And then from there, I moved over to Desktop Metal. And here at Desktop Metal, I do everything. I do the IoT stuff, which is the consoles on the machines. I do the software, and I also now use Qt to actually do desktop applications as well, the kind that you actually download and install. So that's kind of my just the quick version of how I got from being a art school student learning design to now working closely with software engineers, and actually helping them to build things. I do my own front end development. Most UX designers don't. I do it because I'm kind of a control freak, and I don't always trust the engineers to do it right. So I try to give them the front end code. And really, what the front end code is just what you see, like buttons, the drop downs, the animations, but none of it actually works. None of it actually calculates anything or anything like that. So I do like to do that part of coding, just because I'm a big believer that if you know how it gets built, you'll be able to design for it better. Um, so hopefully that gave you kind of a good overview of what I do and how I got to where I am. Let me look at the questions that were sent ahead of time. how did you get involved with Desktop Metal and 3D printing? Okay, so with 3D printing, when I came to Desktop Metal, I really didn't know much about 3D printing. I didn't have a 3D printer or anything, so I actually learned it on the job. And you'll find that in if you work in software, software changes so often that a lot of what you'll learn on the job, and a lot of it is just making mistakes and failing and learning from it. And it's a very forgiving environment. This is one of the things that I love about being in software is everybody's learning something new all the time, and you're encouraged to learn. If you know everything, you're not a good software engineer. That's just kind of a known thing. So it really puts the kibosh on people who are know-it-alls, even though I know they do exist out there. But it's you have to be somebody who loves to learn, and somebody who's a good learner, and somebody who's willing to learn on a regular basis. So I think I explained what my work experience was before my current position. And I believe I explained what I studied. I'll tell you that the majority of the studying that I did was not in college. Sorry to say. It was really in my experience with work. I learned a lot on the job, and I kind of observed. I learned a lot from observing and also looking at what's on the horizon and looking for opportunities that's on the horizon. Like any kind of new technology, I'm very, very interested in, and I'm very curious about. So I always kind of keep a sharp eye out for that. What is it like to work at Desktop Metal? Desktop Metal it's a startup. Although it's a very well-funded startup, it was a startup. It is a startup. It's been around for like a few years now. But it was definitely felt like a startup when I first started, in that, I'd walk into the lab and I'd see like a giant microwave with a million wires sticking out of it. It's not contained at all. There was like giant foaming kegs of nitrogen. And so it felt very much like a startup, like it was scrappy. But we have since moved spaces. We have safety people. We have protocols now. You can't walk into the lab without putting on lab goggles. We have rules to follow, but it is a really great environment in that I get to learn something new every day. It is a pretty lean environment. And the nice thing about lean environment, okay, so the bad thing about working in a lean environment is that there's a lot of work. And so if you don't know how to manage your own time, you could find yourself working nonstop. And because there's just so much to do. But on the flip side, because there's a lot to do, there's a lot of opportunities to learn, and a lot of opportunities to learn about things that you weren't hired to do. And so I've learned a lot about metallurgy. I didn't even know what metallurgy was before I started at Desktop Metal, but hanging out with the PhDs that work at Desktop Metal, I've had a chance to learn a lot about how metal sinters and what it's made up of, the porosity of different metals. I've also learned a lot about machines, like how firmware talks to actual machine parts and makes them move and stuff, and kind of debating the debate of should the high-end software, being the software that the user touches, tell the machine what to do, or should the machine show the high-end part, the UI, what it's doing. So there's always an ongoing debate about that. So 3D metal printing does take longer than a plastic printer just because of the process. The actual printing itself is faster because it is a powerful machine. And there is one thing I forgot to mention is there are two types of 3D printing. There is the filament-based 3D printing that works very much like what a plastic printer, but there's also powder-based 3D printing, which is it lays down a bed of metal powder layer by layer, and then in between each layer, it will release this really high bonding super glue substance that will solidify before the next layer comes on. And so as the part builds, the bed is going down, and so you're building the part that way. I can send out a link to a video that shows that if what I just said doesn't make any sense at all. So yeah, it does take longer because of the process. How much electricity do the machines need to operate? Wow, I really don't know. I'm sure there's somebody that I can ask because we do measure kind of the energy efficiency of these machines. But I could not answer that question for you. So sorry about that. Um, is there any other questions that people might have? Um, let's see. Okay, so I see there's a couple more questions. Um, how big is the furnace? Let me just answer that pretty quickly. The furnace is like the size of it's the size of a ATM machine. But it is for the studio system, the furnace is office friendly, meaning it doesn't have to be vented. Um, and we designed it like that on purpose so that people could have it in their offices. And then the next question is, so the furnace gets to be, I think, it gets up to like 2000 degrees, and that's Celsius. We always measure everything in Celsius. I believe that to be right, but I am not 100% sure. I do know that a lot of different types of metal sinters at different speeds or different temperatures. So what happens when a metal object is being sintered is, at first as it sinters, the heat will go up and then it'll plateau. And as it's plateauing, it gives it time for all the binder material that is in the metal to dissipate and disappear, and then the metal will shrink and basically densify. And then it will heat up again to the sintering point where the metal will actually become a solid piece. And then when it's done, it comes out as a purely solid piece, almost purely. It's like 99.9% non-porous. How do you update your knowledge as the field expands? Okay. So that's a really good question. And so I think the first thing that has to happen is you have to be really curious. I've always been a very curious person, and I've always been curious about technology. And it also helps to kind of have a mentor. Like my brother has always been a mentor to me ever since I was little. He is somebody who was programming, his own video games when he was saving them on cassette tapes. And so he's always been very interested in all the newest things that could potentially change the way we do things. And so I always kind of keep a close contact with him to kind of find out what's going on, what's going on through his head and what he's thinking about. And so curiosity is the number one thing. And then really, if you're really curious about something and you search for it, I'm telling you, it finds you. The knowledge that you look for, it will find you. The people that you can share this knowledge with will find you if you are curious enough to really dig. Like for example, one of the new technologies that I am really, really interested in, because I really think that it could potentially change how we do everything, is the world of cryptocurrency. It's so new and it's so different. It's such it reminds me of when the internet came about, and it took people like several years to kind of wrap their head around what it was. I feel like that's where we are economically with cryptocurrency, Bitcoin, and such. And so as I was looking for more information on that, I stumbled upon a community of UX designers, and they are trying to create a human-friendly guide for all future apps that will be designed for transactions using cryptocurrency, to ensure that we provide some kind of a framework for them to use so that it's as user-friendly as possible. And so part of UX is kind of doing kind of things outside of what you do for your paycheck to kind of try to make the world a more user-friendly place. And so that's kind of my project that I'm working on. And this is an open source project. Oh, there's a whole world of stuff I can talk about with open source in the world of open source development in software engineering that I find very exciting. But maybe that can be for a different different conversation. Um, but
Ms. Sorry, Ms. Arifin. So I was wondering if you had any kind of like words of wisdom for like students that are interested in, going into your field. Just as far as like what are the kinds of classes they should take, what kind of things should they be involved in, and whatnot. So I know you said that most of the things you learned came kind of after college,
yeah,
but
yeah.
since I guess a lot of them are going to college, like what kind of suggestions do you have as far as
So
that goes?
I would say if you want to get into software development, you know, I think the notion is people feel like they have to be really smart with coding, and and I would say coding and programming is just one aspect of what you'll do because the world of software development and software engineering is so vast. A lot of the engineers that I work with, actually what they do are design data models, right? Like how data flows, and they do most of their work in diagrams and user flows. But I will say this, um, coding was by far, just the dealing with syntax and stuff like that is by far the most challenging thing for me that I've had to learn by myself. And so I would say get comfortable with coding sooner than later, and you don't have to learn all the languages. You don't have to learn JavaScript. You don't have to learn HTML, CSS, but, learning the basic, I think you guys in some of the classes you're learning Java, like learning some or C++, like learning some basic languages and learning how to navigate with a terminal as opposed to with clicking and dragging is a good thing to get used to because you'll be doing a lot of that, regardless of whether you're a JavaScript developer for the web or if you're a C++ firmware developer, no matter or even a UX designer, there will always be a need for you to touch code. And so the more comfortable you are with coding, and okay, I don't want to say coding, I want to say using commands to tell the computer to do something. The more comfortable you are with that, the easier it will be to understand when you have to use things like GitHub to collaborate with other people. So my suggestion would be take whatever classes you can to learn code. And if you love it, be a programmer because there's definitely always going to be a need for that. But if you don't love it, there's also other things you can do that's not coding based. But I do think that it's good to feel comfortable and to understand what coding is. And then the other thing is, I would say take whatever classes that sound that sound abstract because the software is very abstract and it's hard to know. Like for example, there are there may be classes on data modeling or framework development, and you may not know what that is, but those are things that are important. So I would say don't be afraid of classes that you don't or things that you don't understand. Just learn about it, and once you understand it, it's almost like with software for me. I didn't understand what something was until I knew enough to understand. Then I'm like, oh, that's why it's like that. That's kind of how my learning process has been. So, has anybody used GitHub? I'm curious to know if you guys use that at school for anything.
You do use it a little bit, yes. I think some of the students that do programming and maybe programming that's a little bit more advanced, we have used that some.
Yeah,
So
it is the most complicated thing to learn, but once you kind of stumble through it as much as you can, it then starts to make more sense. So yeah.
all right. Well, thank you so much for doing this again. I wish we could have had you in person. Last year it was really great. I think the students really enjoyed, seeing and feeling the actual 3D metal parts. But we really appreciate it. Sorry, things were a little bit scattered
That's
today,
okay.
but we really appreciate you taking the time to talk to us. All right.
Sure. It's been a pleasure. And anybody can send me, you have my email, Mr. Wong. Anyone, if they want to reach out to me, they're welcome to.
Yeah, if folks want to just maybe send me any follow-up questions, I can forward them along to Ms. Arifin. Okay. Thank you all very much for tuning in. All right.
Thank you.
Okay, take care. Bye.
Bye.